Hi, I'm Damon Lenski, General Manager for Avantes North America, and I'm here to talk to you a little bit about the collimating lens, Col UV Vis, and how to maximize the use of this lens through its adjustability features. So when you receive your Col UV Vis and you open the box, inside you're going to find the collimating lens itself, which is going to have protective caps on either end, and a very small hex wrench that's included with the collimating lens. So you want to remove the lens caps initially, and then you're ready to start adjusting the lens to your application. Before we jump into how to optimize the use of a collimating lens, I want to demonstrate a little bit in a practical way how a collimating lens works. And as I mentioned in the previous video about collimating lenses, it creates parallel beams coming out of a light source. So the first issue that you'll notice with a light source, this is our Avalite Hallis Mini tungsten halogen light source, is that you can see the projection of the beam coming out of the light source. And what you're basically seeing is a rectangular shape that is an image of the filament that is inside of the light source. So it is the actual filament inside the bulb, and that's being projected through. And you're seeing a lot of divergence of that filament, so it is greatly magnified relative to its size of about 2 to 3 millimeters wide. Now, the Avalite Hallis Mini normally does not come with a collimating lens removed. It normally comes with a collimating lens attached to the front of the light source. And you'll see momentarily why that is. Because essentially, by adding the collimating lens, we eliminate the effect of the filament shape being projected onto the fiber optic, and we get a nice parallel beam projected onto coming out of the light source. And that's what we want, because we're going to attach a fiber optic to that, which is round, and it needs to be imaging on the fiber optic. Now, in order to optimize the use of the Col UV Vis collimating lens, it's often necessary to use the included hex wrench that is inside the box that I showed earlier. It's very easy to use. Simply insert the hex wrench inside of the nut that's on the side of the lens tube. You loosen that, and then you can adjust the lens tube in or out depending upon whether you want more focusing or less focusing on the lens. And we'll show a demonstration of this right now. So I showed you earlier the Avalite Hallis Mini halogen light source. It has its own collimating lens onto it, so we're creating parallel beams, and those are being coupled into this fiber optic cable, which is a 400 micron core cable. And then I have this hooked up to the Avantes TR stage. That's the transmission reflectance stage. And I'm having the light point upward, and we have a small stage plate above that and a piece of white paper on top of that. And this is often a good way to set up something like this in order to be able to determine the size of the spot that's coming out of the collimating lens at the point where you want to be measuring. So I've inserted a hex wrench into the side of the collimating lens, and I have it focused down about as small as we can get it for this working distance, and we're approximately 50 millimeters away from the objective that's leaving the bottom of the stage. And I'm going to loosen that and adjust it, and you will notice that it's possible to increase or decrease the size of the projection of the image of the light source onto this piece of paper. And based on your needs, whether you want to diffusely illuminate a larger area, or would you rather have more of a focus spot onto say a specular sample, like a mirror or mirrored surface, that will determine what is the optimal position for the collimating lens. And incidentally, the size of the fiber core that you're working with, be that 200, 400, 600, or perhaps a bundle of fibers, will determine a lot how that distance should be set. And that concludes how to optimize the use of the Col UV Vis collimating lens.